Hello and welcome to Apache TinkerPop's home here on Twitch. Today we have another TinkerPop Wide stream where we explore the wider TinkerPop community, looking at tools, libraries, graph systems built on the TinkerPop framework, or even applications built on those foundations. And today we get to hear about agentic AI memory systems using Amazon Neptune Analytics and learn about a new NetworkX integration that exists there. I have Andrew and Andy here to talk about these topics. Awesome to have you both. Thank you so much for joining today.
Yeah, for sure. Thanks for having us.
Thank you. Thanks for having us.
Yeah, so, we didn't get a chance to kind of chat at all very much before we jumped on to this stream. I don't know, maybe you could just take a moment to maybe introduce yourselves, and we'll kind of fire up from there.
Yeah, thanks. My name is Andrew Carbonetto. I've been in development here in the Vancouver region for about 20 years. Just kind of on and off, mostly in data management. I've worked in several systems like Elasticache and Redis, Valkey, OpenSearch, Elasticsearch, and so on. And I'm doing a bunch of graph stuff now, which is great. And Andy and I put together some integrations for Gen AI and some graph algorithms work that we thought you guys might be interested in taking a look at.
Okay, thank you.
Yep. Here's Andy. So basically, I'm a developer from Vancouver area. So recently I'm working on some agentic / graph application, and I just find it really useful. And it's really interesting to see how graph can be used, especially in the AI-ish application. Yeah.
Okay, cool. Yeah, this is kind of an interesting topic. I think I don't think we've done anything quite like this so far. We've mostly focused on a lot on new graph implementations, major new features and things that have shown up in different graph databases. But this is really more of a bit of like actual application of these things with agentic AI. So it's kind of nice to have this as like one of the first ones that we do. So with that, I'll kind of turn it over to you folks, and we can go from there.
Yeah, so the agenda is really high level. Is we're going to talk about the Gen AI solution MEM0 with its integration with Neptune Analytics as its graph storage. So Andy's going to give you a quick demo on that, and then turn it over to me, and I'll talk about NetworkX and some algorithms on how NetworkX works and its integration with Neptune as well. So Andy, why don't you go ahead?
Right, sure, absolutely. Just give me a second. Right. Are you seeing my screen? Okay, cool. I see myself. Okay. Yeah. So as you guys might be wonder, okay, agentic AI, cool. Also graph, cool. But how those two concepts combine, right? And actually, this is some area that I've been working on for the past month and stuff. And let me just firstly introduce agentic AI first, and then we can start to bring into the topic of the graph, right? How agentic AI work. So in a nutshell, it's just an agent which actually perform work for you. So I guess you guys have been using all the LLM or ChatGPT-ish system. Those chat assistants pretty useful, but most of the time it's answer a question for you. It doesn't really do things for you. And basically, agentic AI in general, it just take that step forward, not just answer your question, but also perform some action for you. But whenever we are going to that context, then that makes us wonder, the agentic AI itself also needs certain context or memory. If it doesn't have that, how it gonna perform the work for you, right? In this particular case, in a usual LLM setup, which will have the context length. However, based on the I think the current limitation on LLM, there always have a limit memory windows and stuff. So once you get into a really lengthy discussion, the LM will always goes off track because it cannot recall what got discussed before. And basically, memory layer is got introduced because of this, and basically it serves as a stateful layer that which basically keep track of the user conversation and update it accordingly. There are just 2 more slides I'll go through before we enter the demo. I just want to give more information for those who might not familiar with the domain, right? We're gonna skip the rec part, and let's talk about how traditionally memory system be used, right? Before the graph layer exists, most of these memory system actually rely on vector search. You'll have much better concept later when I do the demo. So basically what happened is that whenever you chat with the LLM, which it will attempt to break down your query into sentence and generate the embedding for that. Once it's break down those sentences, it will store into the database, and up on every next response, it will attempt to fetch those similar sentence from the database via similarity search. This works, right? So let's say if you talk to the LLM that if you have a conversation with the LLM last week, let's say, right? I want to make a reservation for a sushi restaurant next 2 weeks. You might not have that like in a system that which without the memory layer, you will the LLM won't be record that fact. However, with a system with memory layer, there will be actually an entrance on entry of a database which record the fact that okay, you want to have you want to book a sushi restaurant next 2 weeks and stuff. Okay, why graph, right? I think people keep asking this. Why graph? Like if vector works so well. The problem of vector search is that it always breaks down your memory segment into sentence bases. And those sentences might often have an ambiguous meanings. However, in contrast, if we break down those conversation into relation in the sense of graph, nodes, and edges, that provide a definite that provide exact definition. There's no ambiguity, and this provide a much more clear and clean concept in terms of memory perspective. Yep. So this is all those background. I'm just trying to make sure that we are aligned before we jump into the demo because yeah. So those are the background for why memory layer, why vector search, and why graph search. And now I'll just jump into the demo, right? Okay, I think there's more exciting part. Okay. So if you can see, I have preloaded. Previously I have run a Python script, which have loaded a paragraph as a background information to the memory system. So which you can see on the top section. As you can see, as the paragraph being entered into the memory system, there are 2 parts happen here. Just like what I mentioned before, the first part is the sentence fragment, which like it breaks down into multiple sentences based on those paragraphs and store it accordingly. Those are the vector part, right? It's not graph. Yeah. So as you can see, this is a really simple introduction of Alice, right? Where she works, where she studies, and what she is interested in. As you can see, those break down into multiple sentences. Cool. Store into vector, right? But then on the second part, then you realize, okay, despite we can store a sentence, but now with the help of the graph system, we can also store as in a relationship. In this case, the source field will always be the author itself. In this case, probably Alice. But as you can see, it tend to produce much more cleaner relationship by instead of storing those sentences, which might need to break down further. But now we only store 1 to 7 7 node and edge pair. And as we go further, we have the second paragraph as well. In the same case, so those are the advantage, I would say, when we are using the graph system also as an add-on for the memory layer. This shows a really clear relationship, and it helps LM to respond better. Is there any question on the chat so far? No? Okay. All right. And in order to examine those relationship, I think that would be better if we can use a Graph Explorer for this purpose. Right. For the time being, I have already loaded the graph for the same, basically for the same instant of the Neptune analytic we have used it on the previous example. As you can see, this graph is actually represent the paragraph that we have loaded just before. As you can see, it's a pretty, like, there are 3 nodes, which is pretty obvious in this graph. I'll explain further, but let's go through those nodes in the center one by one, right? As you can see, under the memory system, in this case, it's mem0. There will always be a center node, which is name is Alice. Basically, this represents the order, or so basically the center of the paragraph or the conversation. In this case, it's Alice, but if you are using it as for you to interact with LM on daily basis, that will be you, right? So basically, instead of storing those sentences like vector search, in this case, we store relationship, right? So let's say Alice have a collaborator, which is a collaborator with Stanford University, and which is an organization on itself, and also what it have. Okay, it present a conference. So this is what the center of the paragraph, and then beside that, you see those 2 nodes which are pretty obvious and pretty standard from this graph. The other one, which is David, if you pay attention to the prior paragraph, so basically David is the partner of Alice, which he also lives in Seattle, and they got married. And that's why the David node or vertex in this case has a really like center position, because as you can see, most of there are a portion of the paragraph that actually also describe David itself. And eventually we have the third node. As you can see, it's always Alice, but this time it got broken down into a separate node, because when the memory system processes the paragraph, it treats this as a different person. This is something that certainly the memory layer can be improved. But what we can see here is that instead of storing that lengthy paragraph with all the different vertex factor, in here on graph, we can actually store those information, and we are seeing how those information overlap and related. Right. So as you can see, so let's say I picked those common nodes actually. Yep. So both Alice and David are also in the domain of healthcare analytic, and also they're interested in graph. They're researching in graph system. So this conclude how graph can help in this particular case. Sure, existing memory system for LM can use vector, but with the graph, with the help of graph, as you can see, the relationship is now break down into more detail, and the relationship is just more clean, and it's really easy to use, because it's so easy for you to take this as a database of user preference And in the future, if your system have to start another chatbot about Alice, you can easily just import this like file, a data source, then you can reuse of it. I think the most wonderful thing is that because how flexible of graph system, as your conversation progress, which I don't have it on this demo, but as you continue to chat with the LLM, actually the memory layer will start to learn from your sentence or the conversation and try to add and drop your preference. So unlike which some other system which use RAG as a knowledge base, which is also cool, but those are more static and more static basis and fact based. But in this case, the memory layers are more like a tailor-made and a custom version of your preference as the user. Yep. So this kind of conclude how memory can be used in this particular case. And then perhaps I will let Andrew to pick up the topic of NetworkX.
Yeah, thanks. So switching gears a little bit, Gen AI memory is what Mem0 is working with, but NetworkX is more graph algorithms. So let me just share my screen. Good. All right, so let me introduce NX Neptune. This is a backend plugin for the NetworkX toolset. It's a Python toolset, and this allows you to integrate with Neptune Analytics. My name is Andrew. I've introduced myself, but quick agenda. We're just going to talk a little bit about NetworkX, give you a little bit of background on what it does and why it might be interesting for you to use. Then I'm going to talk a little bit about the NX Neptune backend that you can add and install. Show you a little bit about how algorithms run in the cloud, and then we'll talk about Neptune Analytics pipelines. A great extra feature. So NetworkX itself is a Python library that you can download and use from PyPy that lets you play with graph networks. So here's a just very quick example of using NetworkX to create a directed graph, add some simple nodes to it, and then add some edges. It's a great little library that lets you quickly play with graphs, import, export, and then run some algorithms. So for example, I'm going to show this demo of the PageRank algorithm. I'm just running it from video so that it doesn't mess up. But in this case, so we're loading the same example graph. It's a directed graph with nodes A, B, C, D, E, and then some edges from A to B. I've got a picture on the bottom in ASCII, A to B to C to D to E, and then back down to C. And the interesting part is we are going to run PageRank on that. So now that we've loaded the data, we can visualize it with NetworkX. It has a neat little visualization tool. And then if we run the PageRank algorithm, we get PageRank results for each of the nodes. So all this is run locally in Python. So now that we know a little bit more about what NetworkX does, it's got 100 or so algorithms that you can play around with your graphs that you import. And it's an open source project. If you want to contribute more algorithms or make them more optimized, there's tons to build out. It's got a fancy backend decorator that you can attach. You can allow your NetworkX data to run in different environments. What this does is when you're running an algorithm, you call the Python code, it may get overloaded into one of the backends. Some of the popular ones involve running it in parallel or running it with a GPU. And we added NX Neptune so that instead of running your algorithm locally, it'll run the algorithm in the cloud on Amazon Neptune Analytics. So all you really need to do is import NX Neptune, another library available on PyPy. And once you import that second library, it'll link in with NetworkX and everything will just work. And then you have to tell NetworkX that you want to run it on Neptune versus running it locally. So you pass it backend equals Neptune as a classifier. So in this case, we're running PageRank with the backend Neptune. All right, demo time. Oops, let me make this bigger. So same example, we're going to create a really simple directed graph with nodes A, B, C, D, E. And we're going to visualize it. We can run it locally and get the same results. And then you can run it with Neptune Analytics. Slightly different output because it's debugging some information, but essentially it's going to Neptune Analytics, sending some OpenCipher requests, and you get PageRank results from Neptune Analytics. NetworkX also allows you to visualize the PageRank results. I think this is really cool. So you can compare the results from running it locally and running it in the cloud. Current algorithm support. So this is the set of algorithms that we currently run with Neptune Analytics on the back end. We're always open to adding more. And come visit our GitHub page, post some issues. If you find any issues, contribute. We're always looking for contributors. And then we're mapping to the Neptune Analytics algorithms list. So you can go and check out the Neptune Analytics list and see what gets mapped. As an extra gimmick on top of this, we can also do instance management with the NetworkX and Neptune backend. So running it locally is really simple because you just load data, but I kind of glossed over the syncing of data between how it loads data locally and pushes it to the cloud. So as you run an algorithm, if there's any data locally, it'll sync it up to the cloud and push it. But it may require an instance in the cloud, and you can do all that management with the NX Neptune plugin. So in this case, you can see that we're just configuring the plugin to create a new instance. So this will create a new graph in the cloud. It'll push that data and then run PageRank on that data. You can even configure it to then destroy the instance at the end if you're done with it. Some other options that you can do, you can create a new graph, you can connect with an existing graph, you can destroy that graph when you're done, you can reset that graph when you're done with it and you just want to reset the data. And then we have the ability to import Gremlin CSV from S3 or export that Gremlin CSV to S3. That's useful because Neptune Analytics allows you to mutate the graph and attach labels to some of the traversal algorithms. And that mutation will update your graph, and you may want to export that graph and bring it back locally or play around with it later on if you'd like. So just a really quick demo of how that instance management works. So here I've got a notebook where I've configured it to create a new instance. And you can see the timestamps on it creating the instance. It's waiting for it to be done. You can import the data from S3. In this case, I'm running a BFS algorithm. And then I can delete it afterwards. And again, it runs through the process of deleting that instance for you. The idea here is everything is just 1 or 2 commands away from executing. It's great for pipelines. All right, that's our presentation.
Yeah, cool. Yeah, thanks for that. I'm going to try something. Let's see what happens here. But there's like a new feature at my disposal. And yeah, there you go. So there's the QR code for NX Neptune if you want to check that out. It'd be cool if we could put a little Gremlin there instead of the little StreamYard guy, but maybe I can figure that out. I don't know, probably not. But yeah, check out NX Neptune. I think that's like seems like a really cool integration there. And really sort of simplify that whole setup. I assume like the alternatives would mean if you wanted to use NetworkX with Neptune, your alternatives would be having to dump the data out, I guess, and somehow consume it. So this much easier with just one simple step. I'll return back to Andy because you did have a question there.
Yep.
So let's pop that up on the screen, and I'll get that QR code off of my head in the process. So yeah, how easy is it to connect AI memory tools to Amazon Neptune?
All right. It's just like 2 steps away. And indeed, I can probably share the screen again just to it's clear.
Go ahead.
All right. Are you guys seeing my screen?
So
on the left are the demo script that I have used with a different paragraph, but like more or less the same. So basically, what user have to do is that they have to log into the AWS console. So there is a video on my right hand side. So this is the screen that you usually see on your AWS console. Once you have created the instance, you get like a graph identifier here, which always start with G. In order to use that, so in this particular case, I'm using Strang, which is like agentic AI / framework. All you have to do is just to take that ID and specify it as an environment variable. So as you can see on my line 15 on the IntelliJ, here is XXX, but you just substitute with your graph identifier. Once you have the environment variable, in this particular case, Strang will just recognize it and will use it accordingly during the conversation to keep track of the user preference.
Yeah, we're trying to follow popular APIs like LangChain when connecting to external data sources. So it should just be comfortable with everybody.
Yep. Okay. Is there more question? Okay, the second one.
sorry, I'm on mute and talking to nobody.
Oh,
So I do have 2 questions from Discord. Let's pop them up real quick. Here we go. So we got this. What are the benefits of using network analytics with NetworkX? As a first question.
Yeah, NetworkX has some backends already built in to help speed up and optimize your performance. But running things in the cloud, well, everybody knows the benefits of running things in the cloud. You can do bigger data. You can play with more public data. You can share data. It persists better. And because NetworkX is mostly just a local tool, it's mostly used for scientific computing. But if you need a pipeline or if you need something to run really in the cloud, you probably want some sort of cloud provider. Right now, there's just Arango DB as a backend provider that's in the cloud, but it doesn't have any algorithms. So Neptune Analytics is the other option.
I didn't realize that was the only one. That's interesting.
There's so much offered with NetworkX. But right now, the only option is if you want to run that data in the cloud, you have to export the data, push it to the cloud, put it in S3 or whatever.
How would you build it? How would you build a TinkerPop backend?
That's an interesting question. So I was looking at some of the TinkerPop recipes that we have available. Some queries through Gremlin. So right now there's no Gremlin integrations. So one thing to build is a Gremlin integration, and then run those recipes. It's totally doable. But right now we're using OpenCipher for Neptune Analytics.
Interesting.
Yeah. And because this is a really convenient way for user to speed up the existing computation, because in alternative, other than using other database like graph database vendor, we also heard some use case that people, because they have to speed up the computation, they will need to actually provision a NVIDIA cluster or equivalent like GPU cluster, so that in order to accelerate the computation on the graph workload. But those are also, it takes some more time, also some more planning on the instance and the provisioning and stuff. And in contrast, or like relatively speaking, this particular integration with Neptune Analytic, all you have to do is create instance, put in the graph ID, and it works. Yeah.
Cool.
Having to do everything through NetworkX is a little bit limiting as well. And being able to go straight to the source is great.
Yeah. I don't know enough about the APIs and things that NetworkX exposes there to really comment, but I think it'd be a nice conversation. I mean, I think people have asked about that integration before, and it's just, I guess no one's really gotten around to making it an actual thing that exists. So it's probably just something like that. Other question, what would be needed from TinkerPop? Oh, we kind of talked about that. What would we need from TinkerPop as a framework to support TinkerPop enabled backend? So to a certain extent, we kind of touched on that. Do you know anything specific at this point that we would need in TinkerPop to make that easier to do?
So right now we're just hooking up with the algorithms in Neptune Analytics. We're calling those directly, and we're letting Neptune Analytics do all the work. For any of the TinkerPop integrations, we would need to have an algorithms API. So we're using calls. There's no defined algorithms. We just have the recipes, which is using the existing queries, which is a little bit, it's not as optimized.
Yeah.
It's optimized through the query rather than through the backend service.
Right.
It'd be really cool to see what kind of APIs we could put together for Gremlin queries, and then just call those directly. And then any TinkerPop data source could optimize that.
Right. Yeah. I mean, there's PageRank. I hear what you're saying. Gotcha. All right.
I mean, NetworkX is a great start on the number of algorithms that you could implement. That API is huge.
And indeed, most popular graph algorithm, the API is pretty static. They're always asking about 2 to 3 variables and parameter and stuff. So I think in a way that if this will, I don't know, somehow goes into the specification of TinkerPop, user can start to have a common API to call, let's say, PageRank. They can always call with, I don't know, 3 parameters, but I don't know, for other vendors, they might ask more, but those 3 are mandatory from TinkerPop perspective. That would be great, right? To start to set up a standard.
Yeah. Cool. Yeah, interesting. I don't think we have too many other questions. I think it looks like Chris and I had a little bit of a back and forth in Twitch, commenting on how much he liked the visualization tool, Graph Explorer. So yes, we do like Graph Explorer. And I think you all might have touched on open source contributions coming to NX Neptune. By all means, try it out and find things you'd like to fix and scratch an itch for sure. Trying to think, is there anything else you folks want to comment on?
So NetworkX is an open source community, great community. They have weekly calls or bi-weekly calls. If you're interested, feel free to drop a line, join in that conversation. NX Neptune is also open source through AWS Labs. If you have any issues or want to make any contributions, please feel free to come and join us on GitHub. There's other open source communities that would love to talk to you.
Okay. All right. Well, thank you all so much for coming on. sharing all the stuff that we talked about today, agentic AI and NetworkX and Neptune Analytics. I think this was a nice session, and thank everyone for listening and joining. We'll see you all in the next one.
Take care.
Thank you.
Bye, guys.
Okay. Bye.